Hello and welcome to the first video in a series where I attempt to answer some LeetCode questions. Around blind 75 LeetCode questions, and I'm going to jump into our first question, which is number of 1 bits. So write a function that takes the binary representation of an unsigned integer and returns the number of 1 bits it has, also known as the Hamming weight. So I'm just going to jump into Paint for a quick explanation of the solution that I have. So the first solution that comes to mind for me in this problem is comparing the number to the powers of 2 in decreasing order. So if we take the number 11, for example, which is 1, 0, 1, 1, then we want to compare whether 11 is greater than or equal to 8, which it is. So because it is, we'll take the new number is 11 minus 8, which is equal to 3. We'll add 1 to the count, count plus equals 1, and then we will repeat this process for decreasing the powers of 2. So our new number is 3, because 11 minus 8 was 3, and our new power of 2 is 4. We check that 4 is greater than 3, so we move on to the next power of 2, which is 2. 2 is indeed less than or equal to 3, so we do as before, where we do 3 minus 2 equals 1, which is our new number. We add 1 to the count, and then we move to our final number, final power of 2 that is, which is 1. Our new number is 1, so 1 is greater than or equal to 1. So we do 1 minus 1 equals 0, which is our new number, which is our final number, and we add 1 to the count, which gives our final count of 3, and there are indeed 3 1s in the number 11 in binary form. So let's code this up. So we'll start by declaring a count variable and setting it equal to 0. We then want to have a for loop which iterates over the decreasing powers of 2. We'll start it at the power of 2 to 31 because we've got a uint 32, so we know that the number is less than 2 to the power of 32. We then iterate all the way down to 2 to the power of 0, which is 1, and we decrease iterator. Then we want to check if the number is greater than or equal to power of 2 to the I. In this case, we want to add 1 to the count, count plus plus, and we want to subtract from the number that power of 2, 2 to the I. Now all we need to do is return, bracket, return the count, and give that a run. That's worked, so I'll submit that. And there we go, saying we beat 45% of people on time and 35% of people on memory. But can we do better? And the answer is yes. Now, my solution is by no means a particularly great solution, and we can take a look at a better solution here, which I will stick a link in the description for. It explains a general overview of bit manipulation, which is a much faster way of solving this problem. You can see a solution here, and I will try to explain this. And I think the best way is to jump back into Paint. So here we are back in Paint, and you can see our solution that we're going to look at in the top left-hand corner here. And over on the right here, we have the bitwise ANDing. So you see that the bitwise AND operator is used in this solution. Now, we have 2 bits, red and blue. If we have 1 and 1, then we get an output of 1, otherwise we get an output of 0. Taking the number before of 11, we can do 11 minus 1, which is 10, which is 1010 in binary, and we're looking to AND our number with 1 minus itself. So, first bit we get a 1, second bit we get a 0, third bit we get a 1, and then a 1 and a 0 gives us a 0. So we get 10 as our output. We want to add 1 to the count. Count plus equals 1. And then we have our new number 10. Now we AND 10 with 1 minus itself, which is 1, 0, 0, 1. And we get 1, 0, 0, 0, which is 8. We add 1 to the count to give us 2, and we do 8 minus 1, which is 7. And then we AND 8 and 7, and you'll see that we are left with 0. We finally add 1 to the count, which gives us 3. And you'll see that here we're doing it while n, which means that while n is not 0. So now that we have 0 and we've set that equal to n, the while loop finishes and the count is left at 3. Now this solution is a whole lot faster than the solution that I wrote up earlier, and that is because we're only iterating for there as many 1s in the solution, whereas I was iterating over every single power of 2 less than 32. Okay, so I've given this solution a quick run to compare it against some other solutions, and I found that it beats 100% of people on the runtime and 74% of people on the memory usage, so that's pretty good. However, I ran it again, and it's only beaten 30% of people on runtime and 35% of people on memory, so it doesn't seem to really make a difference. This runtime statistic doesn't seem to work very well. Anyway, as discussed earlier, this solution is quite a bit cleaner, quite a bit faster, and in general the bitwise operations are much faster than most other things that you can do. So learning bitwise operations is a good thing. I've left a link to the description of this solution here. It goes over a few other problems in the binary section. If you enjoyed this video, please consider giving it a like, drop a comment. If you're confused by anything in this video, write a comment. I'll see if we can get around to addressing it, or maybe someone else can. If you've got a better solution to this question, drop that in the comments too. Subscribe, and I hope to see you in my next video.